So the next example that we are going to start with is a 2D problem. It is an example of a stainless steel tuning fork, and the dimensions of the tuning fork are given below. The boundary conditions that are acting on the tuning fork is given over here in the image. The bottom side of the tuning fork is fixed, and there's a pressure acting on this edge over here, and the value of the pressure is 5 Newton per millimeter. Now the pressure acting is a line pressure that is acting over here. That is why the unit is given into Newton per millimeter. The thickness of the model is 0.005 meter. Now if you consider the thickness of the model as compared to the other dimension is very small. So in this case, rather than considering this problem to a 3D problem, we will consider this to be a 2D problem. So let us see how to solve this problem in Ansys Workbench. We will come to the software. Now as mentioned in the problem, the tuning fork is made up of stainless steel. So the first thing that we need to do over here is we need to set the engineering data. So we'll enter into the engineering data sources, and we will add that material. So in general materials, we will take stainless steel and we will add it. Once that is done, you can see, and then return to project. After that, we will enter into the geometry and we will create the geometry. The unit that you need to set for this geometry is into meters. Okay. Now select the sketching plane and enter into the sketching mode. You can see the model. Okay, we have a radius over here which is 0.025 meter, and the length over here is 0.1 meter. So let us sketch this model. We need a circle whose radius has to be 0.025 meters. Now once the radius has, we have created the circle. After that, now we will draw the lines. Okay. You can use a constraint to create the tangency between the circle and the line. Add the dimension to the line. This dimension has to be 0.1 meter. Now you can create a mirror image of this line. So enter into modify, copy this line, use the center point as the set paste handle, right click, and you can say that it has to be flipped horizontally and paste it again. Once that is done, again you can go into constraints and you can add a tangency constraint to this. Now go to modify and trim the unwanted portion. After that, you can again come into the draw option, modify option, and now you can use an offset option. So in offset, select all the lines that you need to offset. After that, right click and say end selection, place offset, and now place the offset. Once the offset is placed, you can use the draw option again and draw this part. Now give the dimension. This has to be 0.005. So the gap over here, it is a 5 mm width. So if you need to convert the millimeters into meters. Now after that, you need to draw this portion. Okay, you can see very clearly that the length of this part is 0.035 meter and the thickness will be same. So again come to the design modeler. I'm going to use a rectangle to draw this. After that, we will enter the dimensions. This cap has to be 0.035 and this has to be 0.005. Once that is done, you can enter into the constraints and add a symmetry constraint. Now it is placed symmetrically. After this, you can use a modify option, and I can use the drag option over here, select this point and you can drag it so that it starts moving. Once it has been dragged, you can use a constraint again, and I can place this point on this curve, right? And then again trim the unwanted portion. So we don't need this and this part. So with this we have completed the sketch. Okay. Now once the sketch is done, you can exit from here. Now as discussed, because the thickness of the model, the total thickness of the model is 0.005 meters, which is very small. So what we can do is, instead of adding the depth, we will consider this to be a surface model and we will solve this model as a 2D problem. So you can come to concepts, surface from sketches, select the sketch and now generate. So you can see that the surface model has been generated. The thickness for this model can be entered over here, or else you can also enter the thickness of this model in the mechanical window. So now we will take this geometry into the mechanical window. You can exit from design modular and now come back to the project schematic window. Double click on the model cell to enter into the mechanical window. You can see that the model has been imported into the mechanical window, but you can also observe that there's a question mark that appears in front of the geometry node over here. That is because the surface body is missing thickness. So you click on the surface body and in the details window below, you can see that there's a thickness option. So I can enter the thickness over here, but the units that is appearing is into millimeters. Either you convert this thickness into millimeters and enter it, or else you can change the units to meters and you can enter it. So you can enter the thickness. Now once the thickness has been specified, then you can mesh the model. You can use the update option over here to create the default meshing. You can see that the default meshing has been generated. Use the relevance option to make it finer, or else you can keep this on 50 and you can use the sizing option to create default sizing. Okay, so we can observe that the size meshing has been done. If you wish to view the thickness of the model, you can come to the view option and you can say thick shells and beams. So now you can observe the thickness also. Okay. After this, you can again exit from this view, and now we will apply our boundary conditions. So according to the problem description, we have one fixed support at the bottom end and there is a line pressure acting on this edge. The magnitude of that line pressure is 5 Newton per millimeter. So you can come to the static structural node supports and you can add a fixed support on this edge over here. And now we say apply. Now the next option that we are going to see is we need to apply the line pressure. I cannot select this pressure because when you select this pressure, you can see that the pressure can only be applied on faces. As we are using a 2D model and the pressure has to act on this line, I cannot use this pressure. Thus, we'll have to take a line pressure option. So let us come to this option again, line pressure, select the edge, apply, and then enter the value. Now here I need to enter it into per millimeter, so I'm going to change this value and enter the magnitude. Now because it is a pressure acting in this direction, I can come to the direction option and use this edge over here to give the direction. So once that is done, now the boundary conditions have been applied, fixed support and the line pressure. Now in the solutions, you can add whatever solutions you require. So I need the total deformation, we need the stresses, I need the equivalent stress, strain. Let us say if I want the directional deformation, I need the deformation of this model in the x direction. So I can add that, and now we will solve the model. Okay, now once the model has been solved, you can check your results. The total deformation is 47.31 mm. You can check the stress value, right? So it is quite high as compared to the model thickness. The stress value and the deformation is very high. Okay. So in this manner, you will perform a static structural analysis on a 2D model.